Hello, Math Talino and Math Galing students! How are you today? I hope you are all doing well. Come and join me as we discuss another fun and exciting lesson in 4th quarter of Mathematics 9. I am Teacher Badeth, your virtual teacher in this video lesson. But before we begin, let us have first a few reminders. First, stay alert and focus on the video lesson. Second, prepare your pen and your paper for your answer sheets. And lastly, sit back, relax, and enjoy. On my way to our classroom, I saw Dora crying. Her cat is at the top of the tree and she can save her because the tree is too high and the ladder is broken. Would you like to help Dora fix the ladder? That's great! Let us fix the ladder by answering several questions about our previous lesson. Obviously, the answers can be found in the woods of the ladder. Are you ready? Let's begin. First question. What is a triangle where one and only one of its angles is exactly 90 degrees? Do you have any idea? Correct! It is right triangle.
Jump! Jump!
Second question. What is an imaginary line that starts from your eyes and moves out horizontally parallel to the ground? What do you think is the answer? Very good. That is horizontal line of sight.
Jump! Jump!
Next question. What is the angle from the horizontal line of sight of the observer to the object above? Can you still recall? Very good. That is angle of elevation.
Jump! Jump!
What about the angle from the horizontal line of sight of the observer to the object below? Very good. That is angle of depression.
Jump! Jump!
Next question. What do you call the ratios of the lengths of the sides of a right triangle? Do you know the answer? Very good. You call that trigonometric ratios.
Jump! Jump!
Lastly, what is the mnemonic device to help you remember the trigonometric ratios? Obviously, it is SOHCAHTOA.
Jump! Jump!
Very good, students. You did great. You helped Dora save her cat. And I know you are now ready to have another exciting lesson. Problem solving involving right triangles. To be able to solve problems involving right triangles, we must recall our previous lesson. First, the horizontal line of sight. Second, line of sight above the observer. Third, line of sight below the observer. Fourth, angle of elevation. Fifth, angle of depression. And lastly, the trigonometric ratios.
To further understand, let's take a look in this illustration. A boy looking at a bird. The imaginary line that starts at the eyes of the boy and moves out horizontally parallel to the ground is the horizontal line of sight. The line from the eyes of the observer towards the bird is the line of sight above horizontal. The angle formed between the two lines is what you call the angle of elevation. The observer in the previous illustration is the boy. This time, we consider the bird as the observer. Like the previous illustration, this is the horizontal line of sight, while the other line is the line of sight below horizontal. And the angle formed between the two lines is the angle of depression.
To further understand the difference between angle of elevation and angle of depression, let's have another illustration.
There is a boy who loves to play basketball. Let us represent the eyes of the boy as point A, the ball as point C, and the basketball ring as point B. And we represent the endpoint of the horizontal line of sight as point D. The line from point A towards the basketball ring, which is point B, is the line of sight above horizontal. The angle formed between the two lines, AB and AD, is angle of elevation. Next, the line from point A towards point C is the line of sight below horizontal. The angle formed between line segment AD and line segment AC is what you call the angle of depression. This time, let us recall the three trigonometric ratios that are commonly used in solving problems involving right triangles. Line segment AC is the hypotenuse. The opposite side of the angle is line segment AB. Hence, line segment BC is the adjacent side. Sine angle is equal to opposite over hypotenuse. Cosine angle is equal to adjacent over hypotenuse. And tangent angle is equal to opposite over adjacent. To help you remember, you may memorize the mnemonic device, SO, KA, TOA. Since you are already familiar with the geometric properties that may be used in problem solving involving right triangles, let us now apply it. First problem. An observer stands at point 125 meters away from Grand Hyatt Manila Luxury Hotel. The height of the hotel is 318 meters. Perform the following tasks. First, draw the visual image of the problem and then solve the angle of elevation to the top of the hotel. First, we draw the visual image of the problem. We have two objects, namely the observer and Grand Hyatt Manila Luxury Hotel. The distance between the observer and the hotel is 125 meters. The height of the hotel is 318 meters. We now move on to solving the angle of elevation to the top of the hotel. Since the given are opposite and adjacent sides, we are going to use tangent. First step, write the equation of tangent theta. Tangent theta is equal to opposite over adjacent. Opposite side is equal to 318 meters over the adjacent side, which is 125 meters. Second step, solve angle theta by taking the arc tangent at both sides of the equation in step 1. We multiply both sides by arc tangent. Using your calculator, that is equal to 68.54 degrees. Therefore, the angle of elevation is 68.54 degrees. Second problem. An observer is standing on the top of a vertical cliff spots a house in the adjacent valley at an angle of depression of 12 degrees. The cliff is 60 meters tall. How far is the house from the base of the cliff? We represent the observer as point A, the base of the cliff as point C, the base of the house as point P, and the endpoint of the horizontal line of sight as point P. The angle of depression is 12 degrees. The cliff is 60 meters tall. Since line segment AC is equal to line segment DB, therefore, line segment DB is also equal to 60 meters. Since angle of depression is given and its opposite side, we may use tangent. So tangent is equal to opposite over adjacent. That is, tan 12 degrees is equal to 60 meters, which is the opposite side, and we represent the adjacent side as x, since it is missing. Applying cross multiplication, that will become x times the quantity of tangent 12 degrees equals to 60 meters. Since we are looking for x, we divide both sides by 12 degrees, resulting to x is equal to 60 over tangent 12 degrees. Using your calculator, that is equal to 282 meters. Therefore, the distance from the house to the base of the cliff is 282 meters. What about you try to solve the following problems? Number 1. A ladder 8 meters long if leaning against a vertical wall makes an angle of 60 degrees with the ground. How high on the wall does the ladder reach? Second, a tower is 15.24 meters high. At a certain distance away from the tower, an observer determines that the angle of elevation to the top of it is 41 degrees. How far is the observer from the base of the tower? You may pause the video to give you more time in solving. The answers on your activity are: number 1, the ladder reached the wall 6.93 meters high, and x is equal to 17.53 meters. Did you get the correct answers? Very good!
Don't forget the geometric properties that you are going to use in solving problems involving right triangles. First, horizontal line of sight. Second, line of sight above the observer. Third, line of sight below the observer. Fourth, angle of elevation. Fifth, angle of depression. And lastly, trigonometric ratios.
For your activity, answer the following problems in one whole sheet of paper.
That's all for now, grade 9 learners. Did you enjoy our lesson? That's great. You can now get your module and nail it. Remember this quote from the late Kobe Bryant. Great things come from hard work and perseverance. Again, I am Teacher Badeth, your virtual teacher in this video lesson. See you next time!